Welcome to Memory Forensics using Volatility. This is the second session for the series of videos as we try to study and understand this particular domain in cybersecurity. On the first session, we discussed what is memory forensics. We describe as well the importance of using memory forensics. And lastly, we've introduced you to a memory forensics called Volatility. For this session, we will look at on actually running the program itself, just on the basic stuff and just perform basic operations. So why don't you join me, and hope that this will be a productive session for you. On the following slides, we can see some basic usage of volatility. We can notice here that volatility is actually written in Python as mentioned. That's why you will be calling the file and program called vol.py. Moving on, you can see TACF and image. Here we are loading a particular memory image that you are interested to analyze. Looking here as well, you can see a TAC profile, and you will specify a particular profile. Here, it is important to know what type of machine that you're dealing with, especially on version 2.6. When we work on version 3 itself, this particular profile is no longer needed. And next here is the particular plugin that you may use. This is the power of volatility as we try to use these different plugins. As mentioned, there are several plugins that we can use to aid us in our analysis. So that is just the basic format when you try to use this particular tool. Vol.py, TAC info will give us a bit of information on the version of the volatility that we're using. And if you want further help on some of the plugins on how to use and how to use volatility itself, then you can use vol.py, TAC help here, and that will give you plenty of information to help you around. For our demonstration, we will be using memory samples as found on OZapT's file, as you can see here. In this particular link. The volatility GitHub page itself has plenty of memory samples that we can use, but for the purpose of our demonstration, we'll just use this file here, which is linked on the description on this video. Jumping now to our SANS saved workstation, we've loaded a terminal and we will try to run volatility. So the basic format again is vol.py. And we'll try to use the TAC information first. Here you can see that the volatility framework we're using is version 2.6.1, and you can see here plenty of directions and instructions you can use, and so you can get your analysis started for whatever memory file that you have. So as you can see here, it lists down all the profiles available. It also lists down some of those address spaces as well. The important bit for us is in the power of volatility, as mentioned, are the plugins that you can use. Here we will use some of those plugins on our next demonstration. But this is how you can use a volatility here. You can also use volatility.py and TAC help here. Let's say with a particular plugin, let's say we will be looking at information on some of the plugin, let's say with pstree. And here volatility is loading up again, and it gives you a bit of an information on that particular plugin. Moving on now, these are some of the basic operation that we can use for volatility. So first we need to identify the image or some data and information in relation to the memory samples that we have captured. The plugin image info is helpful in that regard. Image info tries to identify or predict for us what is the operating system of that particular image sample, what are the service pack, and also some of the hardware architecture as well. So on this on this plugin, it is able as well to predict and guess what type of profiles we should be using. As you can see here, pscan plugin is much similar to the first one, but this time around it gives us an accurate picture of the profile to use. It provides us the KDBG address header as well in order for us to fully identify what type of memory samples we are dealing with. Again, this is very important, especially as we report on the particular incident as well. On the next is some of those very important plugins that you may use. The first one is the pslist. This particular plugin lists down all the active processes that are running on a system. Again, you will find it very, very helpful, especially as you try to find the snapshot or the status of that particular host on that particular time. What are the services running? What are the processes that are running on that system? Next one as well is the plugin called psscan. Basically, as far as the command reference from this GitHub page as well, it tells us and enumerates for us all the pull tag scanning or that are involved in the particular sample memory file. This can find us all the processes as well, all the hidden processes and terminated processes on your particular image file. Next one is your pstree or your process tree. Here it lists down all the parent process ID of each of the processes that are running on the system. As you can imagine, this is just a helpful tool for you to identify let's say a running process is being executed or is a parent process of another process. So again, it tells you and identifies you which is the root cause of a particular issue or particular incident based on the process and the parent process. So let's continue and let us use volatility to examine a sample of a memory that we just grabbed from that website. The location of the image is shown here. That is this virtual memory file shown here. So let us use volatility, and we'll capture that particular image, tag F, using tag F, and we call 0zap.vmem, and we'll use image info plugin. Again, image info will try to understand and give us information on the Windows operating system or whatever operating system it works, the architecture, and try to also provide information on the hardware that from where this memory has been captured. The important thing to note here as well is that it will predict what type of profile we can use. As you can see here, the suggested profiles that we can possibly use will be Windows XP SP2x86, meaning it can be a Windows XP operating system, Service Pack 2 32-bit, or also can be Windows XP SP3 Service Pack 3 32-bit architecture as well. Another important information that we can grab from this image info plugin is the image date and time, which gives us valuable information, especially as we try to report and finalize our findings on this analysis. So in order to create and predict the correct profile, we'll be using again another tool, another plugin in volatility called KDBG scan. KDBG scan, and it will show us hopefully what could be the best profile to use for this analysis. And KDBG scan comes up with the following suggested profile. We normally look at the top and here the topmost part of the first prediction or first scan, which tells us that this can be Windows XP SP3 x86 profile. So, but it also tells us here at the bottom that it can be SP2 x86 as well. But for our intents and purposes, we will be using Windows XP SP3 x86 for our profile. So let's jump in now and have a look on some further plugins here. So now knowing that we can use Windows XP SP3 x86, so why don't we jump in again to volatility instead of KDBG scan? We'll be using tag profile here equals Windows XP SP3 x86. This time around, I want to know what processes are running on the system at that point in time. We'll try to enumerate the processes running on the system. And that was a quite quick turnaround here. As you can see, we got your systems running. This is your main root systems process here with that has process ID 4, but also it shows us different types of processes and list down all those things for us. We will not do any analysis for now, but we'll consider that in the next few sections. But look at this. There's some interesting processes here that we don't normally see in a Windows environment. Let's say reader underscore sl.exe seems to be an interesting process. We can use another volatility plugin as well called psscan that will scan for the latest processes that has been terminated in the system. So again, we'll look at that particular profile and file as well, and we'll just use psscan here, and we'll just wait for some of those output here. As you can see here again, exactly the same stuff that we are looking at the process list, and as you can see here, lots of processes here that has been terminated or hidden for us. Again, the area of interest that we will analyze later may be this particular executable here. Another useful tool is your process tree. As you can see here, so you can just type in pstree and press enter, and it will list down all the parent processes in pstree process tree here, and it will list down all the processes and parent process ID of all the running services and processes on your system. As you can see here, process ID 4 is the main process for all the system, and it spawns all these particular processes running on the system. Again, something that may be of interest to us is this process here. You got your explorer.exe, and then from there it spawns all these processes. As you can see here, the process ID, parent process ID for this one, VMware user.exe, is 1956, and this one as well, 1956, and our process of interest, reader underscore sl.exe, has 1956 as well. We can probably surmise what could have happened. So you got your explorer.exe, maybe a file forward has been executed, and then from there, all these processes has been spawned all together. So that concludes our session for today. So we look at the basic usage of volatility. We've used some of the basic plugins, including process list, psscan, and pstree. And also we dig through some of the interesting processes that run on a system. I hope that this is a productive session for you. I hope to see you in the next session.